Hello, the Astro 30 here, and today... What, sweet? Can you have another electronics video? Well, I guess, yeah. Yippee. Greetings, the Astro 30 here, and welcome to part 2 of the Subwoofer Pre-Amplifier / filter build video series. And today I'm building the active filter. That's basically the circuit that filters out every other frequency bar the interesting frequencies such as the subsonic that we want to put through to the subwoofer. So I've got the kit here. There was a debacle with this PCB, was not included in the original parts box that we've got here, but that's been sorted out. I've got the circuit board, as you may all know, and I'm ready to assemble it, and I have also reversed engineered it back to a schematic. So we're going to take a look at that in a second. It uses two dual NE 5532 op amps, and has its own onboard 7815 and 7915 voltage regulators respectively. So let's have a look at the schematic. So here is the schematic, and at first glance it may appear a little bit complicated, but it's relatively simple. It's not overly complicated. We'll start from the left and work our way to the right. This is just the power supply down here. We'll look at that last. This is the input stage, and they say it has 10 times the preamplification. And if we use the basic gain formula, which is 1 plus R4 divided by R5, we'll end up with a gain of 11. So this op amp stage here, as a non-inverting stage, has operating around about a gain of 11. The input is actually mixed together via these two 10k resistors, put through the input capacitor, which is a 10 microfarad electrolytic, which is a bad idea. That moves on through this 100 nanofarad capacitor into our first filter stage. Now this is a low pass filter, and according to what I read, it's supposed to filter in two stages, one at 150 Hertz and the second at 50 Hertz. So for assumptive conjecture here, we'll assume that this is going to be filtering at 150 Hertz, so anything above 150 Hertz is cut, and anything below 150 Hertz is amplified by this inverting amplifier. This stage, which is the second filter stage, which is supposed to filter out at 50 Hertz, so you could design a filter that would do right down to 50 Hertz, but I think there was the specific reason for them using two separate filters is because, well, looking back at this one and the input stage here, we've got a non-inverting amplifier, so we have a signal going in that direction into this amplifier. From the output of this amplifier, it's now going 180 degrees out of phase. So the second filter, really, more than anything else, is now correcting that at its output back to the original sine wave that's not 180 degrees out of phase. And the output of that filter then comes through this 68k resistor, and this capacitor here is actually a bypass cap. This is the base pot, or max base, or mega base, whatever you want to call it, whatever they call it. That goes through this 50k potentiometer, and it's basically configured in a standard volume control style configuration. The output of this is then fed into the non-inverting input of the final op amp here with this capacitor here. So this resistor and this capacitor are actually forming a low pass filter. Now when this is rotated all the way to the ground, that means that this amplifier is not going to be seeing any signal. So there'll be no signal at the output. So this is a bypass cap to allow the signal to flow when this circuit is at ground. Conversely, when this pot is all the way clockwise, well, this becomes irrelevant after that. This part here is interesting because this is a volume pot, and I'm not sure whether it's supposed to be a linear pot, and I'll tell you why. Because this is a non-inverting input, this negative input needs to be referenced to ground to bias the op-amp correctly. So basically they're using the volume pot in place of a fixed resistor. If we look over here at the input stage, this is what I'm talking about. Ignoring the fact we've got a feedback resistor here, imagine that was just a continuous loop, a short circuit. We'd still have this resistor here to ground. So this pot is essentially doing the same thing, allowing this op-amp to have an earth reference, but still also controlling the output level to the output. And that's basically the pre-amplifier filter circuitry. Down here we have a bog standard 15 plus minus regulator circuit. We've got a set of 4 1N4 007s is configured as a full bridge rectifier, which we have 015 volt input from a transformer. You could probably go a little bit higher depending on the rating of these capacitors. Got two 1500 microfarad filtration capacitors. That goes into a 7815 and a 7915 positive and negative regulator respectively to form positive and negative 15. We've got some output filtering and bypassing here, and the plus 15 goes to pin 8 of both ICs, and the negative 15 goes to pin 4 of both ICs respectively. And that's pretty much it, the schematic. So this is the base pot and this is the level pot respectively. Now you may be asking, why do they have a separate base pot when the amplifier itself already has a bass control on it? Well, I guess so you can tailor the sound of your 2.0 speakers and tailor the sound of the sub separately to get a even balance in bass, maybe, you know. It's always handy to have an extra bass control to control the subwoofer's bass output, because sometimes you may be driving it too hard and there's way too much bass, but there's plenty of bass on the satellite speakers, we'll call them. But too much on the sub, so you can turn it down. Now with these pots, I want to off-board mount them to the front panel. So the easiest way to do that is I'm going to use some of these 3-pin headers, which I loathe because they are a bastard. Not so much this end, but this end, doing the crimping. There is probably a special tool for this specific purpose. I don't have one, so I just end up using a pair of pliers and magnifying glass and eyeglasses and get thoroughly frustrated in the process. And I'm going to be using shielded audio cable for the connections as usual. And so let's start building the unit. Now it's straightforward as usual. We start with the lower profile components such as diodes, resistors, anything that's roughly the same size. Then I might move up to the IC sockets, the capacitors as in the monolithic ones, or well, they're actually MKT capacitors, and then finally the electrolytics. Maybe the terminal headers, there should be one there, one there and one there. The two regulators, I'm not sure if we're going to have to heat sink them yet, but there is provision because the edge of the IC itself is facing off the board, so you can actually put heat sinks either side if you wanted to. This is a 7915 PI. Now the schematic I've drawn could be using the standard 7915. There are two different types where the pin configuration is slightly different, and I can't think off the top of my head which pins are what, but that's irrelevant. But both of these are flat plastic, and this is a 7815. and they're both fully insulated, so you can actually mount this straight to a heatsink or to the chassis that it's screwed to, for instance, to provide some heat sinking. But considering I don't expect the total current draw of this to be any more than 40 mA at the most, these are 1.5 amp devices. I don't see them generating that much heat at 40 mA. So we're not going to worry too much about heat sinking. So I'm going to mount this in my tool. My soldering iron's been warming up whilst I've been talking crap for the last 10 minutes. And yeah, we'll solder it together in time lapse. Okay, that's the construction of the module complete. It only took around about 30 minutes. Now I was going to install the ANI 5532 ICs, but I thought no. Reason being is I want to hook it up to a DC power supply and just verify that we've got plus minus 15 voltage across each of those ICs, making sure that these regulators are working, etc. Because there's nothing worse than putting 22 volt plus minus up an IC that's only designed for plus minus 21. So what we'll do is I'll put some PCB standoffs on it to prop it up, some fly wires in there. Now you may have noticed during the time lapse there that I was having considerable trouble soldering to these large capacitors. It's mainly because of this humongous ground plane here. It's a hell of a lot of copper and the heat is just sinking away from it. Which is probably another reason why a lot of people that design PCBs with you know, SIP mounted packages and stuff that require heat sinking use the copper trace as a heat sink, because it will take the heat away from whatever is presented to it. So let me just set this all up and we'll hook it up to a power supply, do a couple of preliminary checks and then move on. Okay, got the power supply hooked up, set to 22.6 thereabouts, plus minus. So I'll power it up now and just measure across pin 8 and pin 4 of each IC socket and see if we've got, well, 30 volt there. Okay, nothing's happening. There's 0 milliamps current draw, so it's not drawing any current. There's no short circuits. We have 30.1 volts at both ICs, so we have plus minus 15.5 thereabouts. So I know that that is working and the voltage regulators are working. Now, thing is now, in order for us to get an output, apart from putting the ICs in, is I'm going to need to wire up, well, at least the volume pot, or else it's not going to output anything. But I'll do both, and that's going to be fairly time consuming. So I'll do that off camera, but for now what I might do is I will insert the any 5532 ICs into each socket, ready to go, if I so can. Yep. That's one, and the pins on this one are buggered up. Better. Okay, and make sure to insert them the right way around, or else it's not going to like you very much. Okay, both ICs are now in, so now I'll just go wire up my 2 off-board potentiometers, whatever I've done with them now. They seem to have disappeared. I put them down, I only bought them yesterday too, I put them down and now I can't find them. Isn't that always the nice, handy Australian way? Put something down, then can't find it. Okay, thorough pain in the arse that was. I've got the pots wired now. They're hooked up. I've got the DDS set around about 20 Hertz, 1 volt peak to peak going in. Power supply still at 22.5 volt plus minus. Got the oscilloscope hooked up, and so let's see if we actually get any output. Well, I can see it's moving on the scope. So we have an output, and we're currently at 500 millivolts per division, so we're looking at, well, there's each division, so we're only looking at, I'd say, 500 millivolt peak to peak output, which is interesting to say the least. So let's see what happens when I rotate the volume pot. The scope's a little bit slow. Let's put the volume pot full up, and apparently we're getting 439 millivolt peak to peak. But it's very, very slow. So I'll change the base pot. There we got a significant increase. Significant decrease. So it is working, but that's at 20 Hertz. I might ramp the frequency up to 150. Okay, so it's still passing 150 Hertz. So let's change that frequency again to say 260 Hertz, and it's starting to roll off quite considerably. The output is now at about 125 millivolt. So what I might do is I might crack out the other DDS and DSO, and I'll use that scope. Okay, other DSO is now hooked up and it's a little bit more user friendly. I tend to like that little pocket size one for some reason. Anyway, at 120 Hertz at 1 volt peak to peak in, we are getting roughly 700 millivolt peak to peak out. And that's with the level control full, which is fine, and it does disappear and bugger off to nothing when I rotate the control. Okay, so at 120 Hertz I'm going to adjust the bass pot, which is currently at center. So I'm going to turn him full boost, and we can see immediately that there is quite a significant boost at 120 Hertz. I'll just lose the DSO and adjust the voltage per division. Okay, so at full boost we're getting 6 volt peak to peak, which is yeah, quite significant. So if I now rotate it to full cut and then readjust my voltage per division, even at the lowest setting of the scope, there is absolutely no output. So full cut is not supplying any output, and it's very finicky, like right down at the bottom. Yeah, I just rotated about not more than that much, which is like about 1/8 of a turn, we suddenly have an output. So we are looking at about 8 millivolt peak to peak there. So if I wind it up, it slowly goes back up to where we were, which was about 700 millivolts. It is working, yes. How well? Well, not very. Right, now we're at 20 Hertz. Ugh, finally. And we're outputting 440 millivolt peak to peak there. Not that. Put it back to 60 Hertz. This DDS is stupid. Yeah, so I can see right away with the frequency response between 20 and 60 Hertz, we're sitting around about with the highest output at 60 Hertz. What I need to do is I need to hook it up to a source of input and then hook it out to the active sub and just play around with it and see how it sounds with some music maybe. Okay, I've got the active subwoofer hooked up. This is just a Philips one. It's not all that brilliant. But I'm just going to do the good old blurt test. I've got the volume control down low. I'll turn him up. Oops. I can hear that that's filtering sub bass as it should. So now crank the bass up. Ooh. Crank him down. Of course we have no output now. So that's sort of more like another level control really. Anyway, I'm going to hook it up to the CD player as the sound source for now. Okay, I've got the CD player hooked up to just the left input. I'm not really fussed at this stage. So let's have a listen here. Right, well, we can certainly hear bass, but it doesn't make any sense. So I'm just going to pause that and wind it back to the start of the track. I'm actually going to hook this up to the output of the pre-amplifier of the amplifier over there, and we'll play it with the satellite speakers going at the same time. Okay, that's hooked up now. Certainly does make a difference. Big difference. So let me try another track. That's certainly improving the bass sound floor. No sub bass. Sub bass. For some reason I've got a loose knob. Okay, that's getting annoying. Yeah, that's working. The pots do something. It's really basically like two level controls more than anything else, because I can't get any output with the so-called bass pot rotated all the way anti-clockwise. But technically speaking, we should, according to how it's wired on the schematic. Anyhow, that's neither here nor there. The circuit's working, and it's working wonderfully, as it's doing exactly what it's supposed to be doing. We're not drawing any more than about 20 mA off the power supply, so yeah. The transformer I've got, the 150 milliamp one, that's going to be perfect to power both this and the muting circuit in the case. So now I'm going to have to address the knob on the amplifier for the input selector. It's a bit loose. Could just need tightening. Anyhow, yeah, I'll come back in a sec. Just in case you were wondering what I meant about loose knob. There's quite a considerable amount of movement in that switch. But it actually might be just the switch shaft itself moving inside the bearing. It's only plastic after all. And I did put quite a considerable amount of heat in there when I was cutting the end off. Now it needs to be explained how this all works. See, the thing is, the subwoofer over there is actually pulling bass off of the satellite speakers which are on the floor. That's how sound works. Now, it's very important that the signal is in phase at the subwoofer as it is to the speakers. They have to be in exactly the same phase, or it's just going to sound muddy because, well, basically the bass is going to cancel itself out. So if you ever find that when you've hooked up a 5.1, 7.1 surround sound system or whatever, and you find you're lacking bass, check that you've got your speakers wired in phase with each other, because if they're wired out of phase, you can end up with all sorts of sound problems. But that subwoofer is pulling bass, even across the room, off of those satellite speakers just nicely. Okay, so the next logical thing to do here would be to actually test it on its own transformer that's going to be finally used with. I don't see any major problems. What I might do is I want to make sure that both these modules are going to work in unison with each other, because I do need to have an output mute on this circuit, because when I turned off the power supply and these capacitors discharged, a rude noise came out the sub. So that'll be the next step, is to wire this all in, or drill where I need to drill, and mount these circuit boards into the case. Now for the indicator light for the switch, I haven't figured out how I'm going to be doing that yet, but I'll get to that a little later. But first, what would be a good idea is to basically drill my pilot holes here, or my holes, for the circuit boards and the transformer, mount it, hook the transformer up to that, hook the transformer up to that, and then hook this to that, and then back up to the sub, even though I've disconnected it all and moved it, but that's okay. So yeah, I'll get about doing that and mount some stuff, and we'll come back. Okay, the circuit boards are mounted now, and so is the transformer. I've got the voltmeter set to the AC range across the center tap and one of the windings of the transformer. On the secondary, I've shoved them to the rail because they keep flying around and flinging back on me. So I'm just going to plug it in and see what voltage we get across the secondary. 15.7 on that winding, so close to 16 volts, so it shouldn't have any effect on the circuitry or the capacitors. They're not going to blow, they're only 25 volt, remember. Come across the second half of the winding, 15.7 volt. So there we go. Okay, so I've got the AC secondary hooked up to both circuit boards now, as they should be. I'm going to turn it on, and I'm going to measure across the bridge rectifier here what the DC voltage is. If it was 21.7 roughly, say 22 volt, it should be about 40 to 44 volt across the bridge rectifier. That's theoretically. So I'll plug it in and we'll stand by for blowing up and laughing. Well, the relay engaged. Across the bridge rectifier we have 39 volt, so that's roughly 20 volt per rail, so that's just within the capacitor's ratings. As for what we got across this bridge rectifier, if I could get in there, we have 17.6 volts, so that's well within the capacitor's rating, so I'm happy. Now I guess it would be a good idea to hook the output of this thing to the input of that, so that this circuit's actually doing something with relation to that. Hook it all back up to an audio source and yeah, see what we get. But first I'm going to unplug it, and the relays drop out instantly. Nice. Well, unfortunately these two circuit boards do not agree with each other. All I get is noise on the subwoofer, and well, yeah, it just activates the protection and the relays just drop back out again. I've tried several different earthing methods and it's just not going to work, and even if it did, it produces a buzz pretty much like that when the relay is engaged. So that's not going to work. That means I'm going to have to take that circuit board back out because it's no good in there. I'm fairly disappointed. So I'm going to have to come up with another solution to that. So if you want to add speaker protection to an existing amplifier, this is not the way to do it, because it's running on its own separate AC rectifier, bridge rectifier there, and which means the earth points, reference points for this circuit are wrong compared to the rest of the thing. So I'm going to have to probably make my own muting circuit. It's not that difficult to do. All I need is a diode, a piece of wire going to one side of the transformer, and well, a relay like this, I guess, and just stick it on a piece of bearer board. I don't want to do it that way, but I might have to. But anyway, this is useless. Adding this circuit board to it was a complete waste of time. So I've left the standoffs in there. I have turned the volume down about halfway, and when I plug it in, there's a slight pop there. It's not that big of a deal. And a slight one when you turn it off. So
do not worry, Budgie Bottom. Oil is not lost. You are small like peanut, but one day you grow tall and strong.
Just like a giant peanut. No, all is not lost. What I can do is, before the regulator ICs here, well, on one side, the positive rail anyway, I can run two wires underneath the board, the DC, into a secondary board, one from the AC sense wire back to this circuit board here, which I'm going to have to make, and I'll probably use press and peel method for that. To make the circuit board, I'm going to have to etch it anyhow, and because I still want a muting function, and there's a very simple circuit I can use for that, but it just means making a circuit board to do the job. So I will fix that. That just means that this project's going to go on a little bit longer than I intended or anticipated, but that's life. It won't take me long to make up a circuit board, as I said. Thing is, it also needs to be earthed to the case, which I've done. That's what this black wire here is for. It's all just jumper cable together just to make it work. But I am disappointed and annoyed with this. But it was only like about $4.70, so I don't really particularly care. What am I going to use that for? Buggered if I know, probably nothing. Now, that's the plan. I come up with a different solution for the muting, albeit when I plug it in, it's not that bad, not with the volume down. So, let's say we close out this video here, because it's getting close to drinking alcohol time, by hooking it back up to the CD player and yeah, having a listen. Anyway, I'll figure out something. I'm the Astro 30. If you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. As the links are in the description as usual. Anyway, I'm the Astro 30 saying see ya. Not quite impressed, but it'll do for now. There was hardly any noise there when I unplugged it. Bye.